Hello friends, today I am going to explain one thermodynamics topic in this video. I have already explained some topics in my previous video. I have shared this video on YouTube. Please friend, go watch the video on my YouTube channel and like the videos and subscribe to my channel. Today we are going to discuss one important topic of thermodynamics in this video, which is processes and cycle. What is meant by thermodynamic process and what is meant by cycle? Myself, Donny LS, lecturer, Mechanical Engineering Department, Anand Charitable Sanstha's Diploma in Engineering Technology, ASTI. So we will move towards the contents of the presentations. Today's in this my video, I am going to explain what is meant by processes and what is meant by cycles or thermodynamic cycles or thermodynamic processes. Okay. See friend, this is my presentation. First of all friend, I am going to explain what is meant by process. Let us suppose friend, just a minute, I am going to, yeah. See friend, here this is a piston cylinder assembly. See friend, this is piston cylinder assembly. This is piston, and this is cylinder. And in this piston cylinder assembly, gas is placed inside the cylinder. Now, when the piston is at initial condition or initial state 1, at that time the pressure inside the cylinder is P1. Let us consider the pressure. P1 is the pressure inside the cylinder. At that time, the volume of the cylinder is, we are going to consider V1. V1 is a volume at initial state of the piston. When piston moved from right to left at a particular time, then what happened friend? This gas compresses. And what happened? The volume of the particular cylinder reduces to V2. This is the second state of the system. At this condition, the volume of the system becomes V2 from V1. And at that time, the pressure increases to P2 from P1. Now what happened friends? Actually, initially this is the initial state of that system. After particular condition or after particular time, when we move the piston from right hand side towards the left hand side, at that time the process of compression takes place. What happened friend? The process of compression takes place, and due to which the pressure of that particular gas inside the cylinder increases from P1 to this P2. Let us suppose P1 is 10 bar, then after some time P1 will be the greater than 10 bar, which is nothing but 20 bar or 30 bar, whatever may be the value of that pressure, but value may be chances of the increase in pressure from P1 to P2. And here V1 volume is reduces into the P2 volume. We can measure in meter cube. Let us suppose the volume at particular initial state may be the 10 meter cube or 10 millimeter cube, and after some time what happens? This volume becomes 5 meter cube or less than means volume reduces and pressure increases. So this process is known as compression process. This process is known as the compression process. What happen in this process? What happen, friend? Any change that a system undergoes from one equilibrium state to the another is called as process. Any change of that system undergoes from one equilibrium state. Initially, the initial state is one, which is equilibrium state, and after some time this one equilibrium state is converted into the another final state, or initial from 1 to 2, which is known as final state. So this is known as a process. And when number of states 1, 2, 3, 4 joined by a successive path, when number of such equilibrium states joined by a particular line, or solid line, or particular path, which is known as a process path. See, friend, here the coordinate system, this is y-axis, this is a x-axis. Here on y-axis we can take the value of any property. Let us suppose we can consider here pressure P, and on x-axis we may take the value any another property. I am going to consider here V, means volume. So the change in values of properties at a particular state may change after some process. So initial state 1 becomes state 2, after, which is known as final state. This is final state, and this is the initial state. So this is known as a PV diagram. This is known as a PV diagram. Because on y-axis we are going to consider a property pressure, and on x-axis we are going to consider the value of property B, which is volume. So due to this, we are going to consider here two main properties. We are going to measure two main properties, pressure and volume, and this is known as a PV diagram. Similarly, when we take the value of temperature on this y-axis, and here value of another property on the x-axis, which is known as entropy, then this diagram is known as a TS diagram, means temperature versus entropy diagram. And similarly, enthalpy versus, we can also take here enthalpy versus entropy diagram. So in this way we can draw the diagram for the particular processes. So the series of states through which a system passing during a process is called as path of that process. What happens, friend? When series of states, let us suppose this is state 1, state 2, I already told you, state 3, state 4, state 5, 6 and 10. These series of processes passing through the particular path, then this path is known as path of process. To describe a process completely, see, friend, to describe a process completely, one should specify the initial condition or initial state and final state of the process, as well as path it follows, and the interaction with the surroundings. To describe the process completely, one should specify the initial and final states of the processes, as well as path it should follow, and the interaction with the surrounding. So this is known as a process and process path of the processes. Is it clear, friend? Now we will move towards the next PPT. Just a minute, I have to erase it. We will move towards the next PPT. Just a minute, friend. I have to clear it first. Now we will move towards the next PPT. See, friend, here in this presentation PPT number, second PPT, see towards the figure number A, which is known as slow compression, which is also known as a quasi-equilibrium process. Figure B, which is known as very fast compression or non-quasi-equilibrium process. See, friend, we are going to discuss here what is meant by slow compression, what is meant by very fast compression. Or it is also known as what is meant by quasi-equilibrium process and what is meant by non-quasi-equilibrium process. See, friend, first of all, we are going to discuss what is meant by quasi-equilibrium process. See, let us suppose this is a piston cylinder assembly. Let us suppose this is piston cylinder assembly. When a gas in piston cylinder is compressed, when gas, see here, this is the gas, this is gas. When this gas is compressed in this piston cylinder assembly, when piston is moved slowly, the molecules will have sufficient time to redistribute. These are the molecules of the gas. These are the molecules of the gas. When we move this piston towards the left hand side, the molecules of the gas will have sufficient time to redistribute it, and there will not be molecule pile up in the front of piston. As a result of the pressure inside the cylinder will always be nearly uniform and will rise at the same rate at all locations, and since equilibrium is maintained at all times, and this is known as a quasi-equilibrium process. What happened, friends? These are the molecules of the gas. When we compress this gas by using this piston slowly, at the time required to redistribute this molecule or redistribute or pile up this molecule in front of piston is more, and as a result of this, pressure inside the cylinder will always nearly uniform and will rise at the same rate at all locations, since equilibrium is maintained at all times, and this is known as a quasi-equilibrium process, friend. The slow compression, this is known as or slow compression process. Slow compression process or quasi-equilibrium process. Now, opposite to this process is known as a non-quasi-equilibrium process. Here also, see, friend, here also piston cylinder assembly is given here. The gas is filled in this piston cylinder assembly, but the opposite condition to quasi-equilibrium process is when the gas in the piston cylinder device is compressed suddenly. What happens, friend? In this, when the gas is compressed suddenly, the molecules of this gas near the face of the piston will not have enough time to escape. When we compress this gas suddenly, at that time, what happened, friend? Molecule near the face of the piston will not have enough time to escape, and they will have to pile up in the small region. What happened? They will have to pile up in a small region in the front of piston, and thus creating a high pressure region there. And because of this, what happened, friend? Because of this, what happened? The system can no longer be said to be in equilibrium, and this make the entire process non-equilibrium, and this make the entire process is non-equilibrium. So this is known as a very fast compression or non-quasi-equilibrium process. Is it clear, friend? When processes proceed in such a manner that the system remains infinitesimally close to an equilibrium state at all times, and it is called as quasi-static or quasi-equilibrium process. A quasi-equilibrium process can be viewed as sufficiently slow process. A quasi-equilibrium process is known as a sufficiently slow process that allows the system to adjust itself internally so that properties in one part of the system do not change any faster than those at the other parts. So this is a quasi-equilibrium process. Is it clear, friend? Now we will move towards the next PPT of this topic. First of all, I have to erase this part. Okay, is it clear, friend? Now this is all about quasi-equilibrium process and non-quasi-equilibrium process. Now, see, friend, it should be pointed out that this quasi-equilibrium process is just a minute. See, friend, it should be pointed out that a quasi-equilibrium process is an idealized process, and it is not a true representation of actual process, but many actual processes are closely approximate to it, and they can be modeled as a quasi-equilibrium process with negligible error. See, engineers are interested in quasi-equilibrium process for two reasons, friend. Engineers are interested in quasi-equilibrium process for two reasons. First reason is what? First reason is easy to analyze. Quasi-equilibrium process is easy to analyze. Then second is work producing devices deliver the most work. The work producing devices deliver the most work when they operate on quasi-equilibrium process. This is also important point. These are the two important points because the engineers are interested in quasi-equilibrium process for two reasons. First one is easy to analyze, and second is work producing devices deliver the most work when they operate on quasi-equilibrium process. Therefore, the quasi-equilibrium process serves as a standard. Therefore, the quasi-equilibrium process serves as a standards to which actual process can be compared. The actual process can be compared to the quasi-equilibrium process because quasi-equilibrium process are considered as a standard processes. Note that the process path indicate a series of equilibrium state. Process path indicate what? Process path indicates the series of equilibrium states through which the system passes during the process and has a significance for quasi-equilibrium process only. And for non-quasi-equilibrium process, we cannot characterize the entire system as a single state. For non-quasi-equilibrium process, we cannot characterize the entire system by a single state, and thus we cannot speak of a process path for a system as a whole. See, friend, and this non-quasi-equilibrium process is denoted by a dash line. See, friend, this is a non-quasi-equilibrium process is denoted by a dashed line between the initial and final state instead of solid state line. Is it clear, friend? This quasi-equilibrium process, this non-quasi-equilibrium process is denoted by a dash line or dotted line in between the initial state and final state instead of solid line. So it is clear, friend. These are the important points regarding the quasi-equilibrium process and non-quasi-equilibrium process. You have to keep in mind for the competitive examinations or your university examination, friend. Is it clear? Now we will move towards the next PPT of the today's lecture. See, friend, there are different types of processes are considered in thermodynamics. Which are that processes, friend? See, this word iso word First of all, you must have to know what is meant by ISO. ISO means this word often used to designate the process for which particular property remains constant. Let us suppose P, T, and V. Pressure, temperature, and volume. Also entropy. See, these are the properties of the system, friend. ISO means what? ISO means these properties are remains constant. Let us suppose an isothermal process. In isothermal process, ISO means same, thermal means temperature, friend. In isothermal process, temperature remains constant. Temperature is property, remains constant. For isobaric pressure, iso means same, remains same, baric means pressure. When pressure P is constant, then the process is known as isobaric process. Third process, which is known as isochoric process, in which volume is constant. See, isothermal process, for example, the process during which temperature is constant, and in isobaric process, a process during which pressure remains constant, and in isochoric process or isometric process, this process is known as a isometric process. Also is process during which specific volume remains constant. A system is said to have undergo cycle. This is all about the types of processes. When entropy remains constant, this is known as isentropic process. So these are the different types of processes. We will discuss these processes in next lecture in detail. So this is just introduction about the processes. Now we will move towards the next topic. What is meant by cycle, friend? Let us suppose we are going to discuss what is meant by cycle. A system is said to have undergone a cycle if it returns to its initial state at the end of the process. When we can say the particular system is said to have undergone a cycle if it returns to its initial state at the end of process. At the end of process, the particular system must have to return to its initial state, and this is known as a cycle. That is, for a cycle, the initial and final states are the identical. Let us suppose, friend, this is PV diagram. Just on y-axis, we are going to consider here pressure P. On the x-axis, we are going to consider here volume V. Let us suppose initial state 1. At this initial state, P is the pressure, P1 is the pressure, and V1 is the volume, friend. This is constant, vertical line. This is vertical line. This V1 is constant. This is the initial state. This is initial state of the particular system. After some time, what happened, friend? After a process, after a particular process, a compression process, after a particular process, this pressure becomes P2 and volume becomes V2, friend. This volume becomes V2. Now, at the end of this process, now this process is end at this particular state 2. This process start at state 1, and this process end at state 2. After particular time, the process end at 2, and after that, this final state becomes initial state. Final state become initial state, or when initial state and final state of the system become same, this is known as a cycle. This is known as thermodynamic cycle. What is the process? This is known as thermodynamic cycle. In thermodynamic cycle, the initial state and final state of the system becomes same. So this is all about cycle and processes, friend. I have discussed these two topics here today. Now we are going to stop here. I have taken this topic from these references. Thank you, friends. Today I'm going to stop here. Thank you.